Hello everyone. Before starting the lesson, let's do this warm-up together. What is the independent variable? What is the dependent variable? So in this warm-up, we're going to review a few concepts. The first concept is this idea of a variable. Now, if we look at the table of values that we have, we are measuring shoe size for different people, and for those same people, we're also measuring their height. So the two values that are being measured are shoe size and height. Those are the variables. Remember, variables can have different values, so each person has a different value for their variable amounts. Now, you may not remember what independent and dependent means when we're referring to variables. But this is just when we are comparing two variables, which one depends on the other one for its value. If shoe size depends on your height, or if height depends on your shoe size. Got to think of it that way. That will determine which variable is dependent and which one is independent. So, does your shoe size depend on how tall you are? Or does your height depend on what size of shoes you wear? Well, hopefully you can see that it's your shoe size that depends on your height. The taller you are, the bigger your feet, which means the bigger your shoe size. Whereas the other way around doesn't make as much sense. The bigger your feet are doesn't necessarily mean that you're going to be taller. It makes more sense to say that your shoe size depends on your height. So in this instance, we would say that height is independent and shoe size is dependent. Now we're going to pick up on this in a minute, but just remember that we are focusing on these variables and the relationship between them. This lesson is about relations and functions. Our goal is to determine if a relation is a function. So there's some terminology here. The first word is relation, and the second word is function. We're going to talk about what those are and how to tell if a relation is what we call a function. Now, this course is all about functions, so it makes sense that we're starting with an understanding of what a function is. First, I'll start with the word relation. There is a relation between height and shoe size. So if I take the data that I was showing you in the warm-up, I can make a scatter plot with all these dots, and I will label height on the x-axis because it was independent, and I'll label shoe size on the y-axis because it was the dependent variable. And I can draw a line of best fit through my points, and I can see that there is a relation between these two variables. As height increases, so does shoe size in general. So if you can make a scatter plot and a line of best fit, and there's a clear trend, that means that there is a relation between your two variables. A function is a relation where each value of the independent variable corresponds with only one value of the dependent variable. Another way I could say that is that a function is a relation where each input has only one output. So if I go back to my data here with shoe size and height, I know it's a relation, but is this relation a function? Remember the definition of function. For each value of the independent variable, it corresponds with only one value of the dependent variable. Well, if I look at my heights, here's an instance where these two people have the same height, but they have a different shoe size. Here's another instance. These two people have the same height, but a different shoe size. So, for one value of the independent variable, there are more than one corresponding values of the dependent variable. So, this is not a function. Now let's take a look at some other data. We have students, their ages, and the day they have soccer practice. Represent the relation between students and the day for soccer practice. Is it a function? Well, notice we're not even talking about ages here, so let's ignore the age column for now. For each student, is there only one day that they practice? Well, yes. Now, Craig and Magda practice on the same day, but Craig only has one day that he practices. Magda only has one day that she practices. Stephanie has only one day that she practices. And Amit has only one day of practice. So because each student has only one day that they practice, this is a function. Now, as far as representing the relation between students and the day that they practice soccer, we can do that in two different ways. The first way is called set notation. So set notation is the notation, the writing, the specific way we write a set of data. So in set notation, you start with the curly brackets or curly braces or curly parentheses. As long as they're curly, you're good. Everything inside your curly brackets is part of the set. Now, inside the set, we have ordered pairs. The first ordered pair is the pair of Craig and Tuesday. Craig matches with Tuesday. Next, we have Magda and Tuesday. Then we have Stephanie on Thursday and Amit on Saturday. So now this is the set of ordered pairs that make up my entire function. Now I can represent this function in another way, a mapping diagram. So a mapping diagram looks like this. We have a list of all the students. We have a list of all the possible days that they practice. Notice I did not repeat Tuesday, even though it appears twice in the list. I'm just listing all the possibilities. It's either Tuesday, Thursday, or Saturday. Arrows are drawn from the student to the day that they practice. Because Craig and Magda practice on the same day, both Tuesday, they both have an arrow pointing to Tuesday. Stephanie practices on Thursday, Amit practices on Saturday. So I can represent my function as a table, as a list of ordered pairs in set notation, or as a mapping diagram. Now with the same data, I can look at a different relation. We're going to represent the relation between ages and the day for soccer practice. So here I have the ages and the day that soccer is practiced. So a 15-year-old practices on Tuesday. That's how we write that in set notation, a list of ordered pairs. 16-year-old practices on Tuesday, 15-year-old practices on Thursday, and a 17-year-old practices on Saturday. So here is the relation in set notation. Here's the relation as a mapping diagram. Now, is this relation a function? Remember the definition of a function. Each value of one variable has only one corresponding value in the other. For every input, there's one output. Well, it's most clearly represented in the mapping diagram here. We can see that when the age is 15, there's two arrows coming off of that. There's more than one day for practice if you are 15 years old, either Tuesday or Thursday. So because this input has more than one output, we would say this is not a function. Now, we know that relations can be represented as graphs as well. So if you want to know if a relation is a function, you can use what we call the vertical line test on the graph of a relation to determine if it is a function. Remember, a function has only one output for every input, or you can think of it in terms of a graph as one y value for every x value. So if I take a vertical line and I pass it along the graph, How many points am I touching on the blue function? Only one at a time. There's no spot that has the line passing through more than 1 point. So this first graph represents a function. Let's look at the second graph. At this point, there's only one value that's the line is going through, but here and all through, we're passing through two different points on our vertical line. So because each x value has more than one y value, we would say this is not a function. Now you can also recognize a function from an equation as long as you can identify the shape of the graph. Now recognizing the shape of a graph takes a little bit of practice, and we'll get better at it as we go through this course. But if I look at y equals 2x minus 5, you might recognize that from grade 9 and 10 as the equation of a line, y equals mx plus b form. You might look at this equation down here, y equals 2x squared minus 3x plus 1. You might recognize that, hey, x squared, that must be a quadratic relation, which would give me the shape of a parabola. This one here you might be not be familiar with, x squared plus y squared. If they're both squared, if both variables are squared, then you're going to be drawing a circle. And if I were to draw a line on a graph, it looked like this, a circle would look like this, a parabola would look like this. Now think about that vertical line test. As you pass a vertical line through each graph, would you hit more than 1 point at a time? If yes, then it's not a function. But if you only hit 1 point at a time, it is a function. So a line is a function, a circle is not a function, and a parabola is a function. We talked about a lot in this lesson about functions and how to represent functions. We looked at set notation, mapping diagrams, and we used the vertical line test to determine if a graph represents a function or not. So with this knowledge, you can now practice, and you've got this worksheet. If you run into any issues or have any questions, please reach out, and I'll do my best to help.